consider some more examples like GS HS is equal to 1 upon S. I have to draw the Nyquist plot for this system. For this, first I have to draw polar plot. I put S is equal to j omega. When I put S is equal to j omega, my G of j omega into H of j omega is equal to 1 upon j omega plus 1, and from here my magnitude is 1 upon square root of omega square plus 1, and my phase is tan inverse omega minus tan inverse omega. For this, when I draw the polar plot for this system, my omega I put 0 and infinity, and I have to find magnitude and phase. When I put omega is equal to 0, my magnitude is 1. When I put omega is equal to infinity, my magnitude is 0. When I put omega is equal to 0, my phase is 0. And when I put omega is equal to infinity, my phase is minus 90. So for this type of system, this is my 0 degree, this is my 90 degree, plus this is my minus 90 degree, this is 180 degree. So I got this type of polar plot and its magnitude is 1. Okay, now I draw the mirror image of this system. This is the mirror image, and it is my Nyquist plot, because over here there is no pole at origin, so no encirclement. So I put my formula n is equal to p plus minus z plus, this is the modified formula. Okay, and this is the encirclement of minus 1. Encirclement of minus 1 is 0. Number of poles in right half of S plane 0, so minus z plus or z it 0. So my system is stable because there is no closed loop pole in right half of S plane. Now I consider some another example in which I have two finite poles like GS HS is equal to 1 upon S plus 1 into S plus 2. For this type of system, my magnitude is square root of omega square plus 1 into square root of omega square plus 2, and my phase is minus tan inverse omega by 1 minus tan inverse omega by 2. So I got the values for omega, magnitude and phase when 0 and infinity. When omega is 0, my magnitude is 1 by 2. Okay, when my phase when omega is infinity, it is 0, and my phase is 0 when omega is 0 and minus 180 degree. Okay, and for this type of system, my polar plot, we already studied this type of system, this type of system, this type of polar plot I got, and this magnitude is 1 by 2. This magnitude here is omega is equal to 0, here is omega is equal to infinity. Okay, and direction is this. So I draw a mirror image of this, and this is the Nyquist plot of my system. Again, there is no pole at origin, so this type of system I got. And here is my minus 1 plus 0j, this point. So again, n is equal to p plus minus z plus, and number of encirclement 0, number of right half open loop poles 0, so my z plus again equal to 0. My system is stable. Okay, now I consider some another example. GS HS is equal to 1 upon S into S plus 1 into S plus 2. For this type of system, my polar plot, I directly draw the polar plot. For S plus 1 and S plus 2, I have a polar plot like this. And for when I add a pole at origin, I got the polar plot like, because this shift by minus 90. So when it shift by minus 90, it start from here and it goes from here. This type of system I got. Okay, so now I have to draw the mirror image of this. The mirror image of this is like this, and in this case there is a pole at origin, so encirclement of pi in clockwise direction. This gives me the Nyquist plot of my system. This is the Nyquist plot of my system. In this case, for the stability, I have to put my formula n is equal to p plus minus zc plus, in this case this is the direction clockwise, so I have to find out this point A. If let this is my minus 1 plus 0j, if this point A, the magnitude of this point A is greater than minus 1 plus 0j magnitude, means it encircle this, means in this case when A is greater than minus 1 plus 0j, means this minus 1 is lie over here, so number of encirclement is 1, number of poles in right half 0, and I got, and this is clockwise direction, this is minus 1, and number of z plus 1 is 1. So this type of system is unstable. Then A magnitude of if A is greater than minus 1 plus 0j. There is a second case when magnitude of A is less than magnitude of minus 1 plus 0j. In this case my A lies over here and minus 1 is over here. In this case n is equal to 0, so my z plus is equal to 0, so my system is stable. Okay, so there is a condition based on which I find out the stability using Nyquist criteria. Thank you.